Hi guys, welcome to your first video in a two-part lesson on filling in the unit circle. This unit circle is a very good tool for helping you learn and remember exact trig values. We're going to be using it over the next couple of days to specifically label all the angles in degree measure and radian measure. And so the purpose of today's lesson is to learn about degree measure, radian measure, and what is a unit circle. And then the second part of this video, then we're actually going to talk about what are some of these exact trig values. And part of that then comes from being able to use the unit circle to say what is the cosine of a 30-degree angle, for example. And we can get that right from our unit circle with just a little bit of work. Okay? Now, to talk about a unit circle, the first thing we have to address is this idea of, look, if I start at the origin, if I start at 0, 0, and I take and I make a line segment with a radius of 1, with a length of 1, and I take that line segment with a length of 1 and I go all the way around the origin. Okay, it's not very much of a circle, but you get the idea. This has a radius of 1, all right? And I want to take that point and I want to swing it all the way around the circle so that each one of these points is created by making a radius of 1. So that means that if I go straight to the right 1 unit, I'm at the point 1, 0. If I go straight up, I'm at the point 0, 1. If I go straight to the left, I'm at negative 1, 0. And down here becomes the point 0, negative 1. All right, so using that information then, we're going to be able to break this circle up into smaller pieces. Now, a couple things you have to remember. A full circle is 360 degrees, and so a half a circle is 180 degrees. So continue with that idea. If I start here at the point 1, 0, and I make a 0-degree rotation, okay? To create this unit circle, we're going to rotate in a counterclockwise rotation. Okay, all angles are always created by using a counterclockwise rotation from what we call standard position, which essentially is this line right here creates an angle, okay? Creates an angle as I go from the origin, all right? From my original x-axis, it creates an angle, and that's the angle that we're going to be looking at as we start talking about this unit circle, okay? So as we said before, a full circle, if I go all the way around this thing, all the way around, would be 360 degrees. So if I went half of a circle, this would be 180, okay? If I went half of a half, well, half of a half circle would then become 90 degrees. And I have to move the screen just a little bit here so I can write it down below. But if I break that up now, this is 270 degrees. So what I did is I broke my 360 degrees into 4 equal pieces. Basically, 360 divided by 4 becomes 90 degrees. And then I marked off in 90-degree increments. Okay? What happens if I go ahead and do that again, but this time I break it into smaller pieces? Take my 90 degrees and cut it in half. Well, as you know, that's 45 degrees. Okay, so half of the 90 is 45. Another 45 puts me to 90. Another 45 puts me to 135. Another 45 at 180. Another 45 puts me to 225. Okay, another 45 would put me to 270. And another 45 is going to put me to 315 degrees. Okay, another 45 past that puts me at 360, which is a full circle. Okay? Now the next piece of this then is I want to take a look at what happens if I then go into even smaller increments. Okay, what happens now if I take my 90 degrees right here and I split it up into 3 equal pieces? 1, 2, 3. Well, 90 divided by 3 is 30, so that means this is 30 degrees, 60 degrees, right? And another 30 degrees past 90 puts me at 120. Another 30 degrees puts me at 150. Another 30 degrees would put me at 180, which is perfect. Another 30 degrees puts me at 210. Another 30 degrees puts me at 240. Another 30 degrees puts me at 270, which I already have. Another 30 degrees puts me at 300, 330, and 360 degrees. Okay? Now, way back in the beginning of this video, I'm sorry I forgot to mention these. These are points that we were supposed to put in here before. This is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. Sorry, I was just looking at that as I was recording and said, oh, I guess I forgot to mention that. We already did talk about that, but make sure you have those points in there. You're going to need to know where those points are. Okay? And again, that just comes from having this segment be a length of 1. I'm not going left or right. I'm simply going down 1 unit. So that's the point 0, negative 1. All right, so that pretty much concludes the angle, the degrees portion of this circle. Now we have to talk about something called radian measure. All right? Now, one of the things you're going to learn is that pi radians is the same thing as 180 degrees. All right, and what we use then is radians is just another way to measure an angle. Okay, we've been using degrees as long as you can remember to measure an angle. A radian is no different, it's just another measure, sort of like measuring in feet versus centimeters. Okay, it's just another way to measure an angle. All right, so with that said, we know that 180 degrees is the exact same thing as pi radians. Okay, so now what I want to do is I'm going to pick a different color here. And what I want to do then is I want to take my entire circle and say, listen, 180 degrees is the same thing as pi radians. Now I'm not going to take the time to write the word radians here, but you understand that this is pi radians. Okay? Well, if 180 is pi radians, then 360 is going to be 2 pi radians, right? Because if I double 180, I get 360, so if I double pi, I get 2 pi. Now the next piece of this is a little bit confusing, but really what you have to do is think about fractions here. All right? If I take pi radians and I cut it in half, well, pi divided by 2 is simply pi divided by 2, or pi over 2 is a fraction. This is 180 degrees, or pi radians. So if I break 180 degrees in half, that's 90 degrees, or another way to say that is pi over 2 radians. All right? Well, half of that is simply pi over 4. All right? So each of these increments, the 45-degree increments, basically come from taking pi and splitting it up into fourths, all right? Because I'm breaking it up into 4 equal pieces, 45, 90, 135, and 180. So if I do pi over 4 for the first one, the second one would become 2 pi over 4. This would become 3 pi over 4, and this would become 4 pi over 4. Now, as you know, 2 pi over 4 reduces to simply pi over 2, which is what I already have here, so I'm in pretty good shape there. All right? The next would be 3 pi over 4, and then 4 pi over 4. Again, 4 cancels with 4, and I'm left with pi radians, which is perfect. Okay, let's continue with that pattern on the bottom. We went 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So the next would be 5 pi over 4. The next would be 6 pi over 4. And this one would be 7 pi over 4. Now, 6 pi over 4 does reduce because these are both even, so this would be written as 3 pi over 2. So what we should be able to say now is that 270 degrees is equivalent to 3 pi over 2 radians. All right? Now the last piece of this then is to take a look at these other increments, these other 30-degree increments. All right? And in these 30-degree increments, now what I do is I say, listen, I want to, and it's kind of hard to see, so I'm going to do this in purple now. Okay, there's 1, 2, 3, 4, 5, 6. I'm breaking 180 degrees up into 6 equal pieces, so I did 180 divided by 6, and that told me 30 degrees. Well, 180 is the same thing as pi radians, so if I did pi over 6, well, this first increment would be pi over 6. All right? My second increment is going to be 2 pi over 6. So I'm going to kind of draw an arrow up here. This is going to be 2 pi over 6. The next would be 3 pi over 6. The next would be 4 pi over 6. And the last would be 5 pi over 6. Now, I have to do some reducing here because 2 pi over 6, realize that 2 and 6 both have a factor of 2. And so this becomes simply pi over 3. So I'm going to write it on the line now as pi over 3. All right? The next will be 3 pi over 6. Well, 3 over 6 is the same thing as half, right? Well, we already have that. It's pi over 2. Our next one is 4 pi over 6. They're both even, so this becomes 2 pi over 3. The next is 5 pi over 6, and that does not reduce. The next would be 6 pi over 6. Well, 6 and 6 cancel, and I'm left with simply pi. Keeping that same pattern going, this is 7 pi over 6. The next is going to be 8 pi over 6. And the next is going to be 9 pi over 6, and the next is going to be 10 pi over 6, and 11 pi over 6. Now, some reductions here. 7 pi over 6 does not reduce, that's why I went ahead and put it on the line, but 8 and 6 are both even, so this becomes 4 pi over 3. The next is 9 pi over 6. Both have a factor of 3. 3 goes in there 3 times. 3 goes in there twice, and so this is 3 pi over 2, which I already had. The next is 10 pi over 6, both even, so this is 5 pi over 3. And the last one is 11 pi over 6, which does not reduce. By the way, if I'm continuing with that pattern, the next would be 12 pi over 6. And as you know, 12 pi over 6, 6 goes into 12 twice, then I'm back to 2 pi again. All right? Now, I know that looks like an awful mess. I know that looks like an awful mess. All right? But those are the numbers that you need to be able to be aware of. So I should be able to ask you with that unit circle, what is the decimal equivalent, what is the radian equivalent of 120 degrees? All right, so this says 120 degrees. You should be able to look at your chart and say, well, 120 degrees is 2 pi over 3 radians. All right, so that concludes the first portion and the first lesson of filling in the unit circle. The next one, we'll actually get into some exact trig values and get to figure out what some of these numbers are.